Hello, welcome back to our technology forecasting for strategic decision-making course. And now we are going to discuss a bit more in detail how do we transform the problem which we perceive to the contradiction, which helps us to understand root cause of problem and to understand our problem more formal way. And this, in fact, will help us not only to understand the problem, but it will help us also to find the adequate solution. So, how to formalize our knowledge about problems? For that purpose, we can use the contradiction model, which was well developed in body of research about theory of inventive problem solving, which was originated somehow in the end of 60s in former Soviet Union. And this is a famous theory that today is applied for building different methods for problem solving, for design problem solving, for different kind of situation where we have no solution ready to use. But our purpose is to use this model is not so large. Our purpose is to see how can we use this model in order to purposefully learn about problems. But let us start with some example. Let us start with some example. How do we learn about problem situation? Let me get an example about vacuum cleaner. And vacuum cleaner we like a lot because it can clean our room, but we don't like it so much because normally it's a very noisy device which consumes electricity, but not so much electricity, but it produces a lot of noise. And usually we cannot use this device at the night because our neighbors definitely will not be agree about. When we realize a problem, for instance, like in this situation, that we would like to reduce the noise of vacuum cleaner, we arrive to the question like how to reduce noise level for vacuum cleaner. So as soon that we arrive to such a question, we always are looking for the solution. But before looking for the solution, the good idea is to understand what is behind of this initial situation. The initial situation, we know what is required, we know what do we want, we know what is the desired result, but we have no idea how to achieve that. But if you ask the same question from engineers, the experienced engineers will say that, okay, so if you have a problem with the noise, normally, how can we reduce the noise? We can add some damping materials. If you add some damping materials, like sponge, inside of the case of vacuum cleaner, the noise level will be reduced. So, but in this situation, we have also degradation of other parameters. Such situation we can describe as a couple of contradictions. In body of trees, they name it technical contradictions. And this situation can be represented in words like, if there is a few damping materials, then power of sucking is well. So our vacuum cleaner is very efficient, but the noise level is high. This is most vacuum cleaner that you can find on the market. But if there is added damping materials, do you remember what experienced engineers suggested us? You need to reduce noise, add damping materials. In this case, the noise level is low, it's true, but the power of sucking is not acceptable because the damping materials, they will reduce airflow inside. The dimension of vacuum cleaner will be larger because we need space to put our damping materials. And what is also important, the temperature of fan motor increased because the cooling effect of fan motor will degrade also. So technically speaking, we face with a situation when improvement of one characteristic, like reduction of noise level, lead us to degradation, non-acceptable degradation of other characteristic of our technical system. So this situation we described that we know how to achieve required result, but it will make system worse. This is exactly what we name the technical contradiction. If there is a few damping materials and power of sucking as well, but noise level is high, okay, we know how to, but it makes our system worse. When we continue to study this situation, we arrive to the physical contradiction level, or contradiction of parameters. When we know what is required and how it has to work, but we don't know the working principle. From point of view of physics, why do we have a lot of noise? Because our airflow is turbulent. It is large and turbulent. Large and turbulent airflow produce a lot of noise, but it produces also good sucking effect. The airflow has to be small and laminar. In this case, it will not be noisy, but the problem is that this small and laminar airflow will not provide good sucking effect. The contradiction of parameter, this is a level of physics of the process. If previous contradiction was mostly formulated on the level of technologies, applied technologies, like let's add damping materials, or let's remove damping materials, the physical contradiction explained to us why. Why do we have noise at all? And resolving physical contradiction, if you are capable to resolve physical contradiction, produce us much more powerful solution than resolving technical contradiction, which is the matter of optimization. Okay, let's add few damping materials, or let's add damping materials different way, and let's optimize it with a power of sucking. In our case, in order to predict future of technologies, we use more generic representation of contradiction, which include both the technical context and physical context. What is a contradiction? The contradiction is a model. Okay, this is a model that we use to describe the interaction inside of the system when useful action creates a harmful one. So, and the pattern, the basic pattern of contradiction model that we use for forecasting purpose, we put what are we interested to achieve, in which situation it will happen, what kind of element, feature of element, and value of feature responsible for that, and of course, what will be the negative consequences, and the opposite value of the feature of the same element, which leads us that this negative result will become positive, but unfortunately, our positive result also will become negative. Let me illustrate it using the same problem about our vacuum cleaner in order to make clear how do we fulfill these variables. The contradiction usually is described also in context. It's described in context of question to answer. Do you remember our prototype of contradiction? It is described in context of specific time and specific space. In our case, our operational time is cleaning time. Within this time, in a cleaning space, this can be the room, it can be something larger, or it can be something smaller. We are interested to answer the question how to reduce noise level for vacuum cleaning. Well, our desired result is noise level is low, less than 40 decibel. And we know that we can achieve this result if we will put amount of damping materials a lot. But in this case, as we already discussed, the power of sucking will not be acceptable. Dimension of vacuum cleaner will be larger, and temperature of fan motor will increase. When we will put few amount of damping material, we will achieve adequate level of power of sucking. Our dimension of vacuum cleaner will be acceptable, and the temperature of our fan motor will not increase, but the noise level will be high. If you sum up this part of exercise, the desired result with minimum changes in the existing system, we have to achieve noise level is low and the power of sucking, dimension of vacuum cleaner, and temperature are acceptable, but not all the time. Only within a cleaning time and only in cleaning space. This is very important details that we have to always specify where and when, in which time and in which space. And we can always measure it. In fact, we have to resolve this contradiction not all the time, but just dozens of minutes when we are cleaning. It can be up to 1 hour. And in the cleaning space, and as soon that we are talking about noise, this is more meter cubic because the noise propagates through the air normally. If we have no air, we have no noise. So the representation of the question how to reduce noise level for vacuum cleaner in a shape of contradiction gives us a key in order to understand the problem more profoundly. And what is also important, when we build for each question, for each problem, for each perceived problem, the contradiction, we can interconnect them to the map. And this map can help us to answer the questions through the phenomena that when problems are interconnected, we have a systemic view to those problems. This was a part that I tried to discuss with you a bit more in detail in order to help you to understand how do we make transition from the problem perceived to the deep understanding of the problem, which helps us to predict the future of our system. Because, in fact, the resolving of this contradiction depends on what kind of resources we are going to use in order to satisfy these opposite requirements. We have not to have a lot of damping materials, not a few. We probably will do it even without damping materials, but what is our target is that noise level is low when the functioning of our vacuum cleaner is what is required, adequate. So in advanced course, if you are going to follow it, you will use this model in order to formalize all your perceived problem, all connected problem, collected thanks to the drivers and barriers and thanks to the system operator. Thanks to the system operator, you will use this model in order to formalize your knowledge. This was almost all that I would like to share with you the introductory course about contradiction. Of course, when we start to practice it, you will learn much more interesting things. Okay, do you have any question, Bala?
Very quick summary and something from my experience also. So the summary is that this step, requires that we take one barrier that we have, convert it into a question, which is how to, and then look at what is the operational time, what is the operational zone, or conflict time and conflict zone. That is basically where is the contradiction and when is it a contradiction. Nice example that you gave us with the vacuum cleaner. You can relate to that. And then formulating it into this model of element, feature, and value, and then expanding it. So that's my summary. My own experience is that we can, for getting better at this, take up anything that you see around yourself, any problem that you see around yourself, you're not able to do something, formulate it in contradictions over and over again, and it becomes a sort of a habit. And I find it extremely useful in order to think of any situation you are in terms of a conflict model. I find it extremely useful. Thanks to experts like colleagues like Dimitri, who have introduced me to this way of thinking. Thank you so much. That's what I wanted to share. There are no questions from my side.
Okay, thank you, Bala. And we hope to see you for the next part of our course. And for this part, that's all. Thank you very much.